Yes, today it's a UNI-T UT136B multimeter. I'm going to take a look at it, see what's inside and how well it's built. First thing to note about it is the size. It's a nice comfortable size to work with. It's a small meter, but I find the display is reasonably large and easy to read on it. And just the physical construction, it fits nicely. It's got this little curved bit there, just sort of a nice touch. It fits in your hand nicely, feels good. Tilting bail here, it's not too bad, a little flimsy, but it seems to hold it. Really like this rubber here. It's not removable, it's actually molded in with the plastic. How the edge is beveled here for the tilting bail, you get really good grip there. The problem is they didn't do anything along here for anti-slip, so when you have it down, it slides around a bit. You sort of gotta apply your force just right, or it slides around as you're turning the range switch. The other thing I don't really like about it are these two buttons here. There's no rubber coating on them, they're just plastic, and you push them down, this little raised bevel around the edge there, I guess keeps you from just hitting it sort of accidentally, but it's not very comfortable on my thumb when I push down. I can, you're getting that edge jam into your thumb there. And, you do have the two off positions, which is kind of nice in a way. Personally, I actually like it up in the middle better, but, yeah, and then you got your 4 inputs, so it's got the separate milliamp and microamp input jack rather than having it combined with the volts, the volts and ohms input jack. Some people say that's a plus. Personally, I don't really like it because I have a tendency to just leave my leads plugged into my meter and throw it off to the side of my bench and then go and grab it. And quite often I'll go to read voltage and I won't even check. You just take a look. It's not in the 10 amp jack good enough, and with them side by or on top of each other like that. I've only played with this meter for about 10 or so minutes, and I've already blown the fuse here on the milliamp microamp jack. So one more thing about the physical construction here that you can tell from the outside before I open it up. It's really sturdy, and just gonna torque it here. So I'm gonna hold it and just twist my hands in opposite directions, and like that is really solid. I can't, get over that. There's just, trying to break the thing and it won't even bend. So physically, the plastic and that seems to be a really good quality, good build quality on it. Let's take it apart and see if that carries on inside. Alright, so it's easy enough to come apart. So the first thing that you notice here is this nice little blast shield around the edge, which also probably contributes a lot to the strength because you can see it's quite flimsy now. The battery compartment is fairly well isolated from the rest. Kind of nice how the Pico buzzer has got these spring terminals. See there, it's a small fuse, not a big HRC, but it is, is that just a ceramic or is that a sand-filled fuse on there? That's the one for the 10 amp range coming through with the shunt. Here is the, this is the fuse that I blew, and all I had was a glass fuse to pop in there. It's supposed to be a half amp. I think that's only like a 200 milliamp because that's all I could find. I have to order proper replacement. But you can see here the 4 diodes, so those will be arranged in a bridge fashion to provide protection on the current input. PTC in there. Not seeing any MOV, so not great on the input there. I'm not seeing anything. PTC coming through looks like that is, we got a couple through-hole resistors here, and then this little surface mount guy here. I'm not sure if that if there's a fusible resistor in there or not. So there we go. After a little bit more prying, I got it out. As you see, the input jacks here are they're not great. They're just these split ring things, fairly cheap, but you can see how they've come up and around onto the board instead of being, you know, butted directly in there, so that you don't have the you know, to provide some strain relief on that solder joint. You know, they did go to the effort of putting an isolation slot in, but yeah, in terms of the voltage input, there is no MOVs there to protect you from an over voltage situation. The other side of the board, there isn't much except for the range switch here, and I don't know, I can't quite tell what kind of coating is on there. That is well, it's really hard under the light depending on which way I turn it here. I'm getting different sort of different colors. You know, it's being reflected off the lights here. Looks like it could be a really cheap thin gold plating, extremely cheap, or more likely it is a looks like it might be some sort of a tin plating on there that's just extremely thin, and the copper is actually showing through a bit, so don't expect huge life out of it. You know, they definitely, well, I mean, they got to save wherever they possibly can. The LCD doesn't want to pop off very easily. I don't really want to force it. You know, looking under there, the sole IC that I can see on the board is coated with some epoxy there, so there's nothing really to see. I mean, that's just going to be your input circuitry dividing. So really disappointed with the input protection on this, that they didn't have you know, a couple MOVs in there at least on the voltage input. The current, yeah, it's roughly what there should be, with the exception of the fuses being, you know, these little guys, but those big HRC fuses are ridiculously expensive, and I didn't actually expect to see them in a meter costing this much. Obviously this is here for trimming in these little surface mount trim pots here, trimming them in to get the accuracy. I don't think it would have good long-term stability though, because it doesn't look like there is well, I mean, when your trim pots are just little cheap surface mount single turn pots like that, I mean, yeah, you look at that, there's plenty of room for dirt and crap to get in there, so it's not like they're a high quality sealed unit. So from the $16 price tag, I could have figured that it wasn't suitable, you know, for use as a field meter by you know, an electrician, but electronics hobbyist. It's not not all that bad, but first thing I'm going to do is we're going to just check what the what kind of burden voltage we should expect from this thing when measuring current. So we'll do the milliamp and microamp range here, because the easiest way to do that is just to check the resistance with another meter. I'm getting 5.3, and just check what kind of resistance I have in the leads here. 0.3. So got about a 5 ohm shunt, it looks like, in the milliamp, and that was at yeah, the lower range. So let's just check when we switch to the microamp what kind of shunt resistor we have there. And so about 102. So I'll just do some quick numbers there. So here we just use some basic Ohm's law. So with the 5 ohm shunt resistor, you can see that with 1 milliamp current draw, that'd be a 5 millivolts of burden voltage. So if you had 40 milliamps of current flowing through the meter, all of a sudden you have 200 millivolts drop across the meter, and that can that starts to become a big deal. 0.2 volts when you start talking about modern low voltage systems. You may be dealing with 5-volt logic, but a lot of chips now are 3.3 only. A lot of them have even lower voltages than that, especially if you start getting into things like FPGAs and that, which I don't deal with, so I'm not really familiar, but I know that some of them get down into the 1.8, 1.2 volt range, so that makes a huge difference. Now with the 102 ohm, it doesn't look so bad at first when you're measuring these really low currents. At 40 microamps, you're looking at 4 millivolts. But when you consider that it goes all the way up to 4,000 microamps, which is 4 milliamps, you look at it, that's 408 millivolts of burden voltage. That's huge. I mean, 0.4 volts, that's almost a third of the nominal battery voltage on a AA battery. So it's definitely, you lose some resolution, but once you start to get up, if you can afford to forego the resolution, definitely worth switching down into the milliamp range instead of microamp for taking current measurements. Or get a better meter would be another option, or look at using an external current measuring device of some sort, either one that uses a extremely small shunt resistor, precision shunt resistor with a precision amplifier, so that you simply read the voltage coming off of that, something like the microcurrent. Or I don't know if anybody's designed one or not, but I was looking at some Hall-based current sensors, and they're supposed to have fairly decent accuracy with an extremely low resistance, as there is no actual shunt resistor. It's simply a matter of bringing a trace in around close to the Hall sensor. So that would be a great way to get around this problem, but I mean, if all you have is your multimeter, or you don't have the resources or the access to any other equipment, just make sure you're aware of this. Now, I'm not sure what the shunt was on the 10 amp range, and in order to measure that, you can't just measure it with another multimeter doing what we did there. For that, you have to pass a current through the meter, measure the current, and then take another meter and measure the voltage drop across it. And from there you can calculate backwards to figure out the size of the shunt. So same thing with the milliamps range. Once you start getting up above this, I'm going to assume it's just the 5 ohm shunt right through the whole thing. Unfortunately, you can only select between AC and DC current. It doesn't let you actually set the mode, whether you're in the 40 milliamp range or the 400 milliamp range. But if it was, I mean, you'd see the same thing. Okay, so the last two things, I guess, would be these leads here. I forgot to talk about them before when I was looking at it, the physical build quality. You get the a pair of probes here with it. It's just cheap wire. It's not a nice silicone based stuff. There's no strain relief on either end here. So not exactly the greatest leads. And the other thing was, of course, forgot to check the continuity buzzer. So you can hear it very, very fast, but it's not latched. Not really surprising, you know, considering the price point of the meter. Yeah, beyond that, I mean, I'm not going to bore you with the details of measuring everything. I've taken some measurements with it and compared it, you know, with my other meter here, and they're pretty darn close. So I'd say that it's within a spec. So in conclusion, it's not the world's greatest meter by any means, but for $16, I think it's a fairly decent value for an electronics hobbyist. You know, I wouldn't use it if I was an electrician. Obviously, I'd be looking at getting you know, a Fluke, you know, something that I know for sure won't blow up in my hand, regardless of where I stick it. So yeah, that's it for this video. Till next time.